Hi, if you are someone who is working with data pipelines, you must have had those mornings where something breaks, data goes missing, and you have no clean way to explain what just happened or to get that back. Today, we are going to fix that problem permanently. We are deep diving into Apache Iceberg time travel. So without wasting any time, let's get started. Imagine you just ran a delete on the wrong table. In a traditional data lake, your day is now ruined. Restore from backup, replay the ETL, explain to the boss. But what if your table could remember every state it had ever been in? What if you could literally query yesterday's version with a single line of SQL? That is time travel, and it is not a feature you bolt onto Apache Iceberg. It is how Iceberg fundamentally works. So, further in this video, we are gonna see why time travel matters, how Iceberg snapshots work, and then I'll show you IOMETE console, where we will use SQL editor to build a table and break it on purpose. So before we write any SQL, I want to show you 5 real situations where this matters. Because time travel is not just a cool trick. It solves problems that data teams run into every week. The first is audit and compliance. Regulators ask questions like what did this customer record look like on January 15th? Without time travel, you are digging through backups. With Iceberg, it is one query with a timestamp. The second is debugging bad ETL. When a pipeline runs and something changes unexpectedly, you need to see the before and after. With time travel, you can compare two snapshots side by side and find exactly what changed. The third is ML reproducibility. If you train a model today and need to retrain it 6 months from now with the exact same data, you tag a snapshot at training time and query that version forever. The fourth is disaster recovery. Someone runs a bad merge or delete, you roll back to the previous snapshot in seconds. No downtime, no data loss, no backup restore. And the fifth is safe experimentation. Instead of running new ETL logic on the production table and hoping for the best, you create a branch. Test there, promote if it works, delete if it does not. The original data is never touched. All 5 of these come from the same underlying mechanism, snapshots, which brings us to the architecture. Most tutorials skip this part and jump straight to SQL, but I want to take 2 minutes here because once you understand what's actually happening on the disk, everything else clicks into place. Now this is a metadata diagram. Every Iceberg table has 4 layers. At the top is the catalog. In our case, that is IOMETE. The catalog has one job. It points to the current metadata file for each table. Below that is the metadata file. This JSON file stores the table schema, the partition spec, and most importantly, a list of every snapshot that has ever existed for this table. Below the metadata file are the snapshots. Each snapshot is an immutable pointer to a manifest list. The manifest list points to manifest files, which point to the actual data. Those are Parquet files sitting in your object storage. Now here are 4 things we need to lock in before we write any code. Every write creates a new snapshot. Insert, update, delete, merge, each one produces a new snapshot and the old one stays completely valid. Snapshots are immutable. Once created, they never change. That is why time travel is always consistent. You are querying a frozen point in time. Alright, let me now open the SQL editor and create a new worksheet. I will call it time travel. And this is the whole code. You can see compute cluster is connected at the top. Make sure yours is running before you follow along. First thing, a namespace. Think of it as a folder for our table. Let's run this. Good. Namespace created. Now the table. 7 columns, nothing fancy. Order ID, customer, product, quantity, price, date, and status. 2 things to note. Using Iceberg tells IOMETE this is an Iceberg table, and format version 2 is what unlocks row level deletes, branches, and tags later. Always set this on new tables. Now let's run this. Table is created. Let's now add some data. 3 orders, a laptop, a mouse, and a keyboard. All pending. Let's run this. Now let me verify. 3 rows. At the moment that insert ran, Iceberg silently created snapshot 1. No configuration needed, it just happens automatically. 2 orders have been fulfilled. Let me update their status. Let's run this again. Orders 1 and 2 are now shipped. That update just created Snapshot 2. Snapshot 1 still exists quietly in the background. 2 more orders just came in. Let's run this again. 5 rows. Everything looks healthy. That is Snapshot 3. We now have 3 snapshots, each one a perfect record of what this table looked like at that moment. Now, this is the moment the whole video has been building toward. An analyst wants to clean up some test data, they write a delete, but they get the date slightly wrong. Let's run this. Three rows. Orders 1 and 2 are gone. The pipeline ran cleanly, no errors, no alerts, the data is just missing. In a traditional setup, this is where the panic starts. But we are on Iceberg, Snapshot 3, the version with all 5 rows, is still completely intact. In the next section, I will show you how exactly you get it back.